The Genie Soft NX has up to 16 counters and 16 compares. To use the counter, we click on the counter icon, we select which counter we want, in this case C1, and we add it as a coil. Now each counter can have a count input, a reset input, and a direction input. So in this case, if we right click on here, we can choose whether this is a counting input, in which case it'll show us a CC1, a reset input, in which case it'll show us a RC1, and a direction input, in which case it will be a DC1. If we now click on the properties, by first of all right clicking, going down to properties, we can determine whether the counter is locked, so it won't actually do anything. We can pick the counter we're going to use from this pull down here, C1 in this case. We can define a set point, and we can make the counter retentive, which means when we power down and power back up again, it starts off where it left off. So generally we would be using the counter as being unlocked, and we would have a non-retentive situation. The output of the counter can be compared using compares. So if we click on the icon there labelled P with a greater than and a less than sign, and we put that in as a coil, first of all picking which compare we're going to have, P1, we put that in as a coil, then we can determine whether it is normally open or normally closed, and we can determine on the properties of that compare. So we have here our source of our compare, C1. We have an operator which can be greater than, less than, greater than or equal to, less than or equal to, or not equal to. And we can make that value compared with any of the other counters in there. So we've got the 16 counters, or we can make it an absolute value. Okay, if we select absolute value, then we put our reference that we're going to compare with in there. So if I select C2, that box disappears. And using the compares, we can create all sorts of patterns, switching patterns, or control decisions, depending on what's going on. Let's just show a simple example here. First of all, I'm going to insert a new rung above the existing one there I've put in. So if I right click and then left click, I come down to line insert. And in here, I'm going to put a timer which is going to be producing a pulse output. Now I could be using pulses from external, but in this case we'll just put a timer in there. We'll make that one, put an input on here first. We'll make it a normally closed input so that the timer just free runs without having to do anything on the input. We'll add our timer in here. Oops, T1, put a timer in. It's not going to do it for me. Not quite sure why that's not pasting the timer in there. There we go, it's finally put it in. Okay, we're going to set that as a trigger input, which it is. We go down to properties, and we're going to make it an asymmetric, so it's like an oscillator, with 0.5 of a second on and 0.5 of a second off. So we're going to get a square wave out of there of a 1 second duration. So coming out of T1 here, we have got a square wave. It's counting 1 second duration. So we will take that and we're going to count that. So I've put the output of it up here. There we go. So now every time T1 pulses, it's going to be counted in the counter C1, but I want that to be a trigger input, not a reset input, so make it a counting input. Okay, so that's going to count. Now we're going to make it count up to 4. So we put 4 in as a set point. And when it reaches 4, the output is going to turn on. So I'm going to get rid of that one. I'm going to come up here and I'm going to say, right, counter C1. And I'm going to put my output there. So what I want to do is when counter 1 reaches 4, I want to immediately reset the counter. So I'm going to put a counter back in here again, a C1, and I'm going to convert that to a reset input. So this counter is now going to count 1 second intervals. It's going to count in as 0, 1, 2, 3. The moment it hits 4, it's going to reset, it's going to go 0 again. So it's basically going 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Now I'm going to take a compare here, and I'm going to put compare number 1 at the beginning of the next line. Okay. We'll go into the properties of P1, and I'm going to say that when P1 is going to use as a source, it's going to use counter 1, so C1, and when counter 1 is equal to 0, it's going to give me an output. So I've got counter 1 equal absolute value 0. So I'm going to get an output at this point. So I'm going to use that to turn on Q. So I'm going to turn on Q1 there. We're being very slow. There we go. So if I now run that program as it is, I'm going to get Q1 turning on only when counter 1 is at 0. Now I can do a similar thing here. I can go to a P2. Don't know why it's going so slow. And I can make P2 turn on Q2. And I can say I want P2 to turn on Q2 when C1 is equal to the absolute value of 1. I can do the same for another compare and a fourth compare, and I can go Q3 here, and I can go Q4 here. So if I now go into properties for P3, I'm going to say when C1 is equal to the absolute value of 2, then Q3 will turn on. Likewise for P4, when C1 is equal to the absolute value of 3, then Q4 will turn on. So this will give me a cycling pulse. Q1 is on, then Q2 is on, then Q3 is on, then Q4 is on. And that will just cycle around those outputs. Each output will switch in sequence. So that's how we can use our counter and our compares. Now I've used a timer there as an input, but you could equally just use a standard input which could be coming from a magic eye, a proximity sensor, a bottle counter, or something similar. And you can use all sorts of logic in there to control things. I'm just showing a very simple application of counting and comparing to create an output cycling lamp or something similar. Okay, simple as that. So if I now go into the simulation, when the device is started, and you can see here what is happening. We have Q1, Q2, Q3, Q4. Okay,